Hi, welcome to my video on extra derivatives. And this extra derivatives is showing you when we do the derivative, of d of x of a variable y. So I'm going to show you a trick that I use all the time, which is very, very important, especially when we get to the topic of implicit differentiation later on. Here we go. The derivative d of x of, notice we have all x's here. So d of the d of x of 6x squared plus, we do the derivative of each part because the derivative of the sum is the sum of the derivatives. So this is d dx of 6x, so that's 6 times 2 is 12, take away 1 is 1, 2 take away 1 is 1, and the d dx of 2x is just 2, because that's a linear. Again, that's a 1 understood here, 2 times 1 is 2, and we take 1 away from 1 minus 1 is 0, and x to the 0 is 1. So that's the derivative. Now, notice here, we got the d of x of 4y. So, here we had all x's and d of x. But what do? Well, I do a little tiny trick. I put the d of x here, d here, and go dy of 4y. Notice now I have a y, so I can't do d of x on the y. So by rewriting it like this, because by putting the d here and d of x here, the dy will cancel out. So if I cancel out here, I get back to this. So that means I have dy dx. Now I can do dy in terms of y, and that gives me, like the 2x, it gives me a 4. So the d of dy of 4y is the same as that d of x of 2x. So we can simplify that and put the 4 in front. So this is 4 dy dx. And later on you're going to see that this is going to be called 4 y prime, because dy dx is the derivative of y in terms of x. So if you want, we can say that's 4y prime. Again, I'm doing this rule because I'm going to do some videos on proving some properties using the product rule. I need to know how to do the derivative of d dx when you have a y value. So what about here? D dx, this is a product. So this is the f and this is the g. So d dx, so if I do f times g and do the derivative, that's f prime times g, add on f times g prime. Notice I do f and then g. As I said, a lot of books don't do this. I do it with derivative of f times g, because this is the same pattern you use when you do the quotient rule. And so now we have, this is f, so the derivative is f prime times g, add on f times g prime. So f is x, so that's prime, or I could do d dx here instead of going with, and this is f, and this is g is y, so that's the y prime. Again, right here I could have said d dx on the x times the y, that's the y there, and I could have said f times d dx with the y. So d dx is the same as that derivative there. Okay, so this, instead of following this through, let's follow this through. Let's keep on going with my pattern of d dx. So here we are. So the d dx on x as a 1 times the y, and I got f is, I wrote f here, so that's x, and that's x here. I didn't feel what x was in. Okay, you gotta be careful. So this is x. So d dx on the y is dy dx times d dx on the y. So that's y, that's x, d dx, oh, better be careful. So dy dx and times d over dy, and so this is dy dx, derivative of d dy, derivative of y is 1. So this is y plus x dy dx, which we could also say y and x, and this is d dy dx is the same as y prime. Okay, just be careful. Gotta be careful. So I'm doing a few more examples to make sure. Now we have a sum. This is not a product. So d dx on x squared, and we got d dx on 6y. So d dx of x squared is same. Derivative of x squared is 2x. But we can't do this. So again, dy dx times d over dy 6y. So we can't do d dx with the y. So I rewrite it like this. So that gives me 2x dy dx. So the d dy with 6y is a 6. So that gives us 2x, and I like to put the 6 in front of dy dx. I don't have to, but it's like having a coefficient, a numerical coefficient in front of a literal. So it's like a 6 times x or 6 times a. Number 5, again we have a d dx, and this is a product. So this is f and g, and f times g derivative is derivative of f times g and f times. So I keep writing this down all the time. Keep writing it down, remind me. So I get the derivative of f, so it's d dx on the f, which is x cubed, times g, you gotta remember. So derivative of the f, which is x cubed, times g, which is y squared. Add on. Now I got the f, which is x cubed, times derivative of g. So I get y, d, better be careful now, d dx on the y squared. So I'm doing the derivative of the g and the derivative of d dx. So here d dx on x cubed is 3x squared times y squared, and this is x cubed, and I can't do d dx with a y, so we make it dy dx times d over dy of y squared. So this gives us 3x squared y squared. This is x cubed, and dy of y squared, dy dx. So the derivative dy of y squared is 2y. And we simplify that, and it gives us, let's see, 3x squared y squared. That's okay. Now this is a 2y, so I'm going to multiply 2y by x cubed, so it gives me positive 2x cubed y dy dx. dy dx. And I want to rewrite that as 3x squared y squared plus 2x cubed y. And dy dx could also be called y prime, which is the derivative of y in terms of x. And you'll see many more of these being done later on. So what about d dx on this sum? So this sum is d dx on 5y squared minus d dx on the 3y. Notice both of them are y's now. There's no x's here. So I have to change it. So this is dy dx d dy. And again, I'm explaining it each time. So later on in the next video, I'm going to take a shortcut. But right now, I find if I keep doing this all the time until I get used to it, everything is okay. So this is dy dx d dy of 5y squared is 10y. And d dy dx d dy of 3y is a 3. So this is 10y dy dx minus 3 dy dx. And if I wanted to, because there's both dy's here, I can go 10y minus 3, like factoring, and I go dy dx. And if you want to change it to y prime, so it's 10 y minus 3 y prime. Again, d dx in terms of y, you'll always end up with a y prime. So another right here, this is a y prime, this is a y prime. So that's 10 y prime minus 3 y prime, which ends up to be, if you want to factor the y prime out, there it is there. So every time you do a d dx with a y, you'll always get a y prime. And this is again a sum, so this is d dx on y cubed plus d dx on 2x plus d dx on 1/2. Because the derivative of the sum is the sum of the derivatives. So again, we got a d dx with a y cubed, so we got to go dy dx d dy. So I'll make those changes. And here I don't have to change it because this is a d dx with 2x, so that's just a 2. Here I make the change, dy dx d over dy. And so this is dy dx. So d dy of y cubed is 3y squared plus 2. And this is dy dx. And d dy of 1/2 y squared. 1/2 times 2 is 1, so that's just a y. So what we have is 3y squared dy dx plus 2, and we have y dy dx. And we want to change the dy dx to a prime, so there's 3y squared y prime plus 2, and this is y prime. And the last one to do, I made this one a little bit different because here I have a sum. So this is d dx on the first one, which is 1/2 x to the 6th y squared, plus d dx on 3y. But this one is a product, and this one is just the derivative here. So this is a product, so this is f and a g. So f times g prime is f prime times g plus f g prime. So d dx here is d dx on, we do the derivative on the f, which is 1/2 x to the 6 y squared times g, which is y squared. Oh, that's my mistake. That's not supposed, because this is the f, this is the g, so there it is. You gotta be careful. And now we go f, which is a half x to the 6th, and now we do y squared, which is your g, and we do the derivative. And I should have put a d dx, I'll put the d dx behind it. So you got to be careful. And so this is d dx on 3y. So I looked at the product first. Product of f times g derivative is derivative of f times g plus f derivative of g. There it is there. There's the derivative of f times g. This is f times the derivative of g. And right here, this one is okay. So d dx on half x to the 6th. Half times 6 is 3x to the 5 y squared. But this one is a half x to the 6th. Now the derivative here is we have y squared, and we have a d dy dx, and right here again it's the same, only it's on the other, d dy dx times d dy, and you see you get used to it. So here I got it on the other side, so there it is. It's just same as this. Now this one is already done. It's 3x to the 5y squared, and right here I do the derivative, so it's plus, and d dy on y squared is 2y dy dx, plus I have dy dx, and the d dy of 3y is a 3. So we simplify this now. We have 3x to the 5y squared. Half times 2 is 1, so it's x to the 6th y dy dx. And right here we have a 3 dy dx. And if we want to write it with a y prime, 3x to the 5y squared. And this is x6, and dy dx is y prime. 3 dy dx is y prime. So that's extra practice, but the next video will shorten this up. So once you get used to it, notice every time you do a d dx with a y variable, you always end up with a y prime. You always end up with a dy dx and the derivative of this function. Again, right here, you got a d dx on y cubed, so you'll end up with dy dx or y prime, and you do the derivative of this as if this was x cubed. So y cubed is 3y squared, but it's y prime, or it's dy dx. So this brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.